Okay, let's start. Let's get my camera set up correctly. Okay. No alcohol tonight. This stuff, which I believe is a French soft drink. It's delicious. It's really nice. This one's strawberry flavors. Really good. Who've we got here then tonight? So we've got Mr. G, Colts, Gildan, Foray, Mr. Jacob, Prince Face, Stepz, Andy Magic Knight. Sure I don't miss anyone. Microman. It's quite a lot tonight. Andira C64, welcome. I don't think I've seen you before. Welcome along. Cheers Wicked. Rockamaya, DMX87. Foray, I think I said already, but if not, he gets a second one. Acmafin, Logica464, another new name, I think. Actually, no, I do recognise that name, I think. Hi guys. Cartoon is over, curtains open. The camera looks really dark, but I'm sure that will change as my screen fills up with bright text. So, yeah, so tonight I wanted to do. Sit down a little bit. The music is loud, okay. Oh, it is really loud. Yeah, you're right. There we go. How's that, guys? Hopefully that's a little bit better. So we're in Chris Hulsbeck mode tonight. I thought I'd dedicate each of these streams to a different, one of my favourite kind of artists from the C64. So tonight it's Hulsbeck's turn. Quite a lot of stuff on there. So presented your game .cosmos actually on my German YouTube channel. Love that game. Thank you very much. I've probably watched that video at some point. I've tried to watch as many of the .cosmos videos as possible. Who's this man? Yeah, I do have a bit of wine, but I'm saving it for the weekend. So I've been really sleepy this week. The last 2 nights I've just slept all the way through from like stupidly early till the next day, and even tonight I fell asleep at about 6 o'clock. I woke up around about 8:45. So yeah, which means I won't sleep tonight, but yeah. Such is life. Got some kind of message down. Let me just check what this is. Okay, that's somebody sending me a private message, but I can't answer that now while I'm on stream. Sorry about that. Okay, so I wanted to look at keyboard routines. Count the torrents. I wanted to look at keyboard routines because it's something that keeps cropping up in the Discord. I think everybody's kind of had a go at it in some way or other. And keyboard is quite a new thing to me as well. I've not really done a lot of it. And I had this idea for this routine not long after finishing Luma. And I wanted to try making it. I was going to do it kind of in my own time, but I thought, why not share it on stream? Oh, Andy, stop stirring. Okay, so I guess the first thing to talk about is how the keyboard kind of works on the C64. So the easiest way to think about it with any of these 8-bit machines that use keyboard matrices, which is most of them, is as a series of wires. So the way I like to think about it is if you imagine a wire running across here and another wire running across here. Let's do 8 wires. So there's 8 wires in each of these, like so, and each one of these carries a signal. And then likewise, there's wires going the other way as well. So the wires are crossed over like so. This is going to be really hard to duplicate now, so I'm just going to do it like this. So what you end up with is basically a grid, like so, with wires running one way and wires running the other way. And a key is pressed when these two wires touch. So you imagine this is a keyboard now, and the wires are suspended above each other. If you press down on any one of where the wires cross, those two wires touch, and that key becomes pressed. It's a very simplified way of how it works. It's a little bit more complicated than that, but you have a new theory. You're working on Lunark. Dearie me. So this is how I like to think about it, as an array of kind of wires that are crossed over like this. And what this means is you have well, you can actually see this if you look in at a keyboard matrix. So this is the keyboard matrix for the C64. There you go. I told you I'd light up a little bit. Now, weirdly, this layout actually refers to the columns, as you'll see in a minute. DC000, and the columns actually refer to the rows. But you can see each key lives somewhere on this grid. So by joining these two wires together, we produce the letter D, and so on through all the keys on the keyboard. And so the reason it's done like this is because you can then represent every key on the keyboard with just 16 wires, and one for ground as well, so 17 wires. I think there's a few more than that actually in the keyboard connector. I'm just trying to look now inside my Ultimate to see how many there is, but it's a very simple way of doing it, and it means that there doesn't have to be any kind of multiplexing done by the hardware. It's just a straightforward, these two wires are touching. And if you open up a keyboard, you'll see the kind of membrane. Well, you don't really see it on the Commodore one because it's all tracks, but on something like the Spectrum, you will see the kind of the plastic membrane that's in there is basically layered. So you have one layer which consists of the wires, the column wires, if you like, and the other membrane which consists of the row wires. Thank you for the host, Sinlau, and thank you for the host, Andy Magic Knight. Appreciated. So ghosting is when you press multiple keys and some of them don't register. So that kind of depends on the hardware itself. So some hardware is very good at it. The Commodore, I think, starts ghosting after about 3 or 4 keys, but we'll see tonight. As I say, I've not really done much in the way of keyboards, so I've not had a chance to experiment with it. But the routine I'm going to give you will allow you to check any combination of keys to see if they're pressed together. Now, you have to bear in mind that some keys won't just simply won't press together no matter how hard you try. So we'll do some tests around that anyway. So the way this works on the Commodore, the way this works in code is that you have 2 values in memory. You have DC000 and DC01. So DC000 is the columns, which annoyingly in this diagram is actually the rows. It does tell you at the bottom, rows refer to column memory address DC100. But if you actually look on the same site, DC100 keyboard matrix columns, so and DC01 rows. So I'm going to label them as such here, but the same diagram that they've produced is actually kind of backwards to what they're saying. So you'll also notice that DC00 is joystick port 2 and DC01 is joystick port 1. And so this introduces some additional problems, and the way that we get around this is with a direction register. So DC02 and DC03 are what are called data direction registers, or DDRs. Now what these do is these define whether you can read or write to these values here. So by default they are both set to, I believe they're both set to 0. Let me just check. Yes, they're both set to read only. So by default these are, let's do it with binary. And what this means is if you read the values in these locations, you will get the read values from these. So if you look in the memory map, you can see that that will give you joystick values. So you'll get, reading the values from DC00 when this data direction register is set to this, will read the joystick port 2, and likewise this will read joystick port 1. So in order to read the keyboard, what we have to do is we have to turn these bits on to be able to read the data in that direction. So if we set these all to 1, like so, then actually reading the value from here will not give you the joystick, but what it will allow you to do is you'll be able to write a value to this and define which column you want to read from next. So the way we work the keyboard is we tend to set all the values in DC02 to 1, like so, basically turning the columns into a write register. Then we write a value to DC 00. So by default the value will be this, which is all the columns, and it's we need to hold the line low, which means basically if we want to read a column we have to set that column to 0. So this is now saying read column 4, so 0, 1, 2, 3, 4, and then we can read a value in here and it will give us whichever keys have been pressed in column 4. So it's a little bit confusing to grasp at first, so let's go ahead and write some code to demonstrate that. Can you make it so the joystick and keyboard work at the same time? I couldn't get that to work yet. If you're using joystick port 2, there's no reason that you can't get them to work at the same time. The trick is, at least I think the trick is, as I say, I'm not really used to this, so please correct me if I'm wrong, DMX. Hi Sinlau, welcome to the stream, dude. So, oh, you hosted me as well, so yeah, I said thank you for the host and then I said hello, but whatever. The trick I think seems to be is first of all use port 2. This is why port 1 is a nightmare. But using port 1 will show keyboard kind of usage anyway. I mean, it's handy if you want to make a keyboard and joystick, because then you can just use spacebar on fire, but not so handy if you want to do keyboard at the same time. But the trick is to I think, and what I'm going to do tonight is to read all the keyboard values that you need and store them, then turn the joystick back on and then do your joystick routine, and you should be able to pick up both things. Now I'm not sure how the joystick, moving the joystick at the same time as pressing keyboard keys, affects that. That might be what you're talking about. So I'm not going to go too much into that now, but if there is a fix for it, please let me know and we'll have a go at it. So I'm going to start just by creating a usual program. So basic upstart to entry is just going to be our entry point for kick assembler. This is also I'm going to use this as an opportunity to demonstrate some of the features of kick assembler that we've not touched before. So we've done macros before. I'm going to go into functions this time, which are similar to macros in a way, but instead of writing code, they take some inputs and return a value. And we'll also look at using lists as well, which is something which is very useful specifically for things like this. So Why did they not dedicate a separate address for the joysticks and the keyboard? Yeah, so it's basically two chips. So there's CIA1 and CIA2. So the CIA1, I believe, is the keyboard and joystick controller, and CIA2 is for things like serial I/O and a few other things as well. It does actually say on the memory map, I think, on here. Yeah, CIA1 input, keyboard, joystick, mouse, dataset, IRQ control, and CIA2 is at DD100, and for some reason my page is not filling in. There we go. It's a serial bus, RS232 and NMI control. Okay. And those are the two 6526 chips that live on your on the Commodore board, which is why if you have a problem with your keyboard and the joystick, the first thing to do is take your Commodore apart, switch the two CIAs over, and see if you get things working. Turn off key scan while reading joystick, but this means keys and joy. Yes, exactly. So yeah, that's what I'm going to do. Yeah. It destroys both joystick ports. Okay, no, this should not destroy both joystick ports. So I'm gonna do a quick demonstration of how to read a key on the keyboard, and then I'm going to show you well, I'm going to experiment with a technique I've been thinking about for a while. That's going to allow you to create very simple macros for kind of key pressed, key down, key pressed, key released. So you'll be able to have three kind of events from any key on the keyboard. So kind of similar to what most people have probably used in more modern high-level languages. And yes, just to note that this is not going to be using the kernel. So actually, the first thing I'm going to do here is I'm going to turn the kernel off. So I'm going to load 3501, disable kernel in basic. I'm not fussed about IRQ, so I'm not gonna mess around with those. Just gonna basically turn the kernel off, so that will do for now. And we'll have a main loop here, which we'll jump to. Let's do that there. Okay. So I will put a little delay in here, so it only reads once per frame as well. So I'm just going to load the value of D012. Actually, I'm going to do it this way. Okay. So now anything I do in here will happen just once a frame. So I'm going to create a routine. I'm going to call it key scan. And I'm going to show you how to read a single key on the keyboard. In the comments it says destroys both joystick parts. That's a text entry routine, not a gameplay keys routine that you gave me. Keep an entry of high scores, not for in-game keys. It does keycaps on the joystick or keyboard high score entry. Okay, this routine could do it. I'll explain. Let me just demonstrate how to enable how to read one key, and then we'll look at the more specific routine. So the routine I have in mind, you'll be able to read whether a key has just been pressed, as in you'll just get a single event when the key goes down. You'll be able to get a single event when the key is released, in case you want a release rather than on press. And you'll also be able to read if a key is held down as well. So okay, right. So what we need to do, key scan. So the first thing I said, like I said before, is you need to turn on the data direction register. So the first thing we need to do is we need to make sure that this value is not a joystick read anymore, but is a keyboard write. So the way to think about these is if you can read a value from one of these, then you're going to read keyboard value. You're going to read joystick values. If you can write a value to this, then you're setting up the column or row that you want to read from. Now, You can do it the other way around. You could do DC01 first and then read DC00, but people tend to use joystick port 2, so it's better to use this and basically make joystick 1 a bit kind of tricky to use. I'm going to change their mind the day before release, yeah. Okay, so key scan. I'm going to do this in a scoped area just so it's a bit easier to kind of pull out later. So first thing we need to do is we need to set data direction register to allow selecting export column. And it's really simple. We just store that at DC02. Now, at this point, if I was to read the joystick, I would get incorrect values. It wouldn't read the joystick properly. So at the very end of this routine, restore joystick control. And we do that just by setting all those bits to 0 again. So now anything we do in the middle here is going to be related to the keyboard, and when this routine exits, we get that joystick control as well. I think the default for joystick to work is FF. That's why I had to make some joystick work. FF in DC00. No, DC02 it will be. DC02 is your data direction register, as you can see on this map here. So it's this one here. So the reason why you have to set FF is because you have to set DC02 to all ones so that when you read from joystick port 2 you get proper joystick control. Otherwise what you're going to read is well, in fact I'm not sure what you get when you read those values, but so with that value set we can then select a column. Again, we're just going to read one key here. So if we have a look at our map now, bear in mind again, as I say, these are the columns this way. Weirdly, I don't know why it's been done this way around, but it has. So let's say let's pick a key. Let's go with F7. Okay, so we want to know if F7 is being pressed. So we need to basically use the first column. And so the two values here, again, I'm not sure why it shows both values here, but basically you want the second value in this column, because what you want to do is you want to turn off that bit. So it's the first column, so that means all of the columns are enabled, and the column that we want to read, we turn off like that. And we store that at DC100. So now, if we read something from DC01, what we will get is the value that signifies whether or not a key has been pressed. So we will get a value if any of these are pressed. I'm just going to show you that by storing that in the border, and we'll press a couple of keys while this runs, and you should hopefully be able to see. Did I forget? Forgot. You should be able to see the border change colour as I press those keys. So if we look at the keyboard map again, so let's bring that up here. So if I press a key that's not in the map, so 3 for instance, don't see anything. But if I start pressing keys that are in the map, so you're not seeing any of them for some reason. Why am I not seeing them? Let's have a look. What have I done wrong here? Is this actually running? Let's just check that this is running. Okay, it's not running, that's why. And oh, because this should be star -3. There you go. I got my little delay loop on. That's why. It's still not running, is it? Just take that out of there a second. Maybe it's my little. Oh, I know why. It's because I've disabled the kernel and basic, so I do also need to disable these CIA routines. So CIA is also used, as was pointed out, for hierarchies and NMIs, and they're used by basic to do various things. So if you don't turn them off, they may be in the middle of running, and generally they will be in the middle of running. So there you go, you can see. And you can see how certain keys will flash the border different colours. Let me just turn that back on and turn that off. And bring up our map again. So yeah, if I press like 3W, actually we are getting some colour changes there, which is weird. Maybe it is using that column. But we should see a colour change for everything on this list. So insert, delete, return, cursor left and right. Not seeing anything like that. It's probably the same colour that's there. The F keys as well, F0, F5, F3, F1. We won't see them because they're the upper areas, so we're not going to see it. We're only going to see on the lower ones. So in order to check that these values, these keys are being pressed, what we need to do is we then need to AND the value we get from this column here with the key that we want to check. So we're going to check for F7. And so all we need to do is we need to AND it with the column that we want. So in this case, we want the 0, 1, 2, 3, third one. So 2, 4, 0, 1, 2, 3, yeah. Like that. So this is just going to check that one bit there. If that bit is set, then nothing has been pressed. So if it's non-zero, we'll go to here. Otherwise, we'll increment the border. And so now what we should see, hopefully, is if we press F7, the border will flash colours, and no other key should do that, in theory. So pressing some keys. Yeah. And then F7 does indeed flash the borders. I think this is where ghosting comes in as well. So certain combinations of keys may actually trigger that as well. So there you go. Oh, D does as well. So I don't know why D. Oh, so make sure that you turn your joysticks off for this as well. Or else you are going to get confused with joystick 1 anyway. Joystick 2 is kind of fine. But that's why we're seeing flashing there. So pulling right on the joystick is seemingly the equivalent of pressing F7, which is kind of interesting. Hey C64 Mark, welcome to the stream, dude, and Chromo Sundrift as well. Welcome, guys. So yeah, that's the simple kind of way of doing this. Now, obviously, doing this for every single key that you want to deal with is going to get messy, right? Because you're going to have to do this with every single column and every single key one at a time. So my idea is to break this down into a couple of different tables, basically. So we're going to have a key down table, and this is just going to contain. I'm just going to put them in manually. I mean, I could use the fill command here, but I'm going to do it like this, so it's obvious. And then this is going to be the key pressed table. And we also need key down previous table as well. So we're using 24 bytes here, and what we're going to do is we're going to, in the key scan, we're going to select each column one at a time, and then after each column, we're just going to read the value from DC01, and we're just going to push it into the key table here. And we're just going to go all the way along until we've got every column. So the key down table will contain a list of the DC01 values. So let's put this in here. Contains the current DC01 values for each column. these, technically, the previous one should start blank like so. And key down previous is basically going to contain what in the last frame this key down table contained. So we always start with FF in each one because that's the default with no keys being pressed. And then the key press table is going to take each of these values and it's going to EOR them together. It's going to exclusive OR them together. And what that's going to do, this is going to give us a list of the keys that have changed, just the keys that have changed. And we can use that combined with the key down table to work out if a key has just been pressed or a key has just been released. And we'll make a macro that you can then use to read these. So you call the key scan once per frame, and then once the key scan has been performed, you can use these macros to grab whether a key is being held down, whether a key has just been pressed, or whether a key has been released. So let's just move these comments around a little bit. It's a bit to read. This one contains the previous for each column. And then this one will be and the great thing with this is it's going to remove the need to debounce any of the keys. So as long as you use the macros that we'll create, you should be able to read a key value if a key has been pressed, and only if it's been pressed once, and that's it. So you'll only read it if the key is pressed down, or if the key is released, however you want to do it. And you won't need to debounce any of these keys. They'll automatically be handled by this routine. That's the plan anyway. As I say, I've not tried this before, so this should be an interesting experiment. Okay, so let's have a look at how we're going to achieve this. So we set the data direction register to allow us to use these columns, and now what we need to do is we need to actually read these columns. So this routine needs to change. Let's get rid of this bit. What we essentially need to do is we need to cycle this number with this 0 moving all the way along here. So the easiest way to do this, I'm going to create some temporary variables. I'm going to do it here, but you may want to move this into 0 page. But for now, I'm just going to do it here. Key column, I'll call it. This can be by 0, it's fine. I know I'm going to store that at key column. Let's just get rid of this. Let's just think about how we would do this. So what we want to do is we want to move that 0 all the way along here while simultaneously putting 1s at the beginning here. Well, that's just a roll instruction. Precisely, it's a roll to the left instruction with a carry set time, and we'll need to do that. We'll need to do the contents of this 8 times. So we'll set the Y register to be 08, and this is the loop that we're going to do. Now. So we'll do whatever we need to do, and then we will set the carry flag. Oops. And then we will roll the contents of key column. And that will basically move this 0 all the way along. And then if we decrease Y, and while Y is not 0, jump back to here. You could do branch if not equal, or you could do 7 branch if plus. It really doesn't matter. In fact, let's do it with this, because I think that's probably... yes, I think we're probably going to need it this way around anyway. Actually, no, we're going to need to go forwards through it. So let's actually do it like this. I'll explain why we need to do it forwards in a minute. So now this value is, so this loop is continuing 8 times, and each time this value is going to change. So the first time round it looks like this. Then the next time round it's going to look like that, and then the next time round it's going to look like that, and so on until we get the 0 right at the end, which means we're going to activate each column one at a time. So we are changing the value in this each frame, so it seems a bit of a waste because we've just set it up here, but we need to read it again here so that it's so that the loop catches it every time. And we need to store that at DC00, yeah. So now we've set the column. So let's put a little note here to say what this is doing. Select the set the mask for the next column. Select the column. And now all we need to do is we just need to read the value in DC01, and we need to store that in our table. So it's just going to go in this key down table for now. And we use $Y. That's why I wanted to go forwards, because we're reading column 0, so we should be storing it at index 0. When we read column 1, we'll store that at index 1, and so on and so on. Okay, so let's give that a run and just take a look at it in the debugger. I am going to, it's kind of unnecessary, but I am going to align this column here, just so I can see these neatly in the debugger. Okay, so let's make it bigger. Let's scroll down to the area. Let's have a look. So it looks like this is it's this row here. Okay, so we keep an eye on this row as I press keys, and if I bring up this table, hopefully we should see values change. So here's our key down table here, 08388. I know it's that because it's the one that's purple, so it's being written to all the time. It's been written every frame. And then if we have a look here, so this is column 0. So this is column 0 here. So if I press any of these keys, the number in this column should change. So I'm going to press some of the let's press return in here. Oh no, because it's going to make me try and write in there. Damn it, it's annoying. Sometimes it can be a bit of a pain because certain keys will trigger things in the debugger. So like pressing F7, there you go, F7. You can see it changes here, and so it's basically turned off bit 4. No, sorry, bit 1, 2, 4, 8, bit 3, and yes, indeed, bit 3 is F7. Interestingly, it shows the hex value F7 as well, which is just a coincidence. So if I press F5, we should see the value BF in here, which we do because you can see here the values at the top. It tells you what they should be. So if I press F3, we should see DF. Cool. And again, if I move to another one, so let's go to the other end of the table. Let's go to this one here. If I press the number 2, we should see F7 in this last one here, which we do. So now we've got a list of the current keys that are being held down, which is really useful. How do you know it's that row? Yeah, using this table. So I'll drop this link in the chat. Which is your keyboard matrix. I don't know why they've done it this way around. It should be kind of rotating 90 degrees because it's from the same site that the memory map comes from. The memory map calls it columns and rows, and this is rows and columns. So that's pretty cool. That's the simple part of it. So the next part is to take that value and EOR it with the previous key down value. So we have that value in the accumulator. So now what I'm going to do is exclusive OR it with a key down previous table, $Y. And then I'm going to store that value at the pressed table, $Y. So what this is going to do now is this is going to actually, let's do it. Yeah, let's leave it like that. Let's not clear the previous table. Let's just leave the previous table as it is. And what you should see is as I press keys, they will appear in the other row, in this row here, which is our key press table. Now, the key press table is going to, because we're using exclusive OR, it's going to be the inverse. So where we were seeing F7 we would instead see 08 and so on. And this will appear and it won't disappear because we're not clearing it yet. But that will be the next step. This is actually going a lot smoother than I thought, so it's pretty good. It's quite a simple routine, really, when you think about it. It's not that complicated. It's just confusing at first because of the way that it shares with the joystick, so it does catch people out. And for a while, when I was doing Luma, I had my joystick enabled, and I got all those values by reading the values one at a time, instead of looking at a table like that, which is what I should have done. And so when I handed the file to Cheers and the others who were testing, they reported that the codes weren't working properly. Certain keys weren't working, and that's why, because it was actually trying to read joystick values instead of keyboard values. Okay, so let's have a look again. So if we press F7, we see that this value here goes to F7. So we should see this value here go to 08. So let's check that. Okay, we don't see that, so it's not saving it for some reason. Did I actually run that, or did I not? Oh, I actually loaded that value. I should have stored that value. There we go. I think what confused you while writing Luma was the bottle of tequila. Yeah, it really didn't help, did it? We were making really good progress, and then the tequila came out, and it suddenly slowed down an awful lot. Okay, so here we go. Here's our key table here. So press F7, and you can see. Actually, it does clear. It clears because it's reading the value from here. But you can see it's if I'm holding it down, it tells me what key it is. But we're going to change that behavior in a second. We're going to use macros to make this super easy. But you can see now we've got the kind of line low value of F7, and we've got the inverse here of 08. And likewise, if I press 2 over here, oh god, it's giving me stuff on. Sometimes this debugger is a pain in the ass. It really is. On there. Yeah, see, there you go. I'm pressing the 2 key, as you can probably see on my no board in the bottom corner there somewhere. And you can see the values in that column have changed, and we can see that it's gone to F7, and indeed our inverted one is 08. I did LDA when I should have STAs. Thank you very much, Buzzley. Hey, old school coder, welcome to the screen, dude. You still don't understand EOR? Okay, let's explain EOR very quickly then. So if you've got binary number like so this is what we've got for one key being pressed. If you this is the key down table, a value from the key down table, and this is the key previous table. So if I do an EOR between those two, what an EOR is it's an exclusive OR. So in JavaScript it would be this same thing would be for B 1 2 3 4 1 1 0 1. It's this symbol in JavaScript. I think it's the same in most other C style languages as well. But basically what it means is if the 2 bits are the same, it's a 0. If the 2 bits are different, it's a 1. So what we get here is we get same, different, same. So this is the value that is going to end up in the press table. Now, why is that important to do this? If you imagine we've now pressed this key down, so if we store this value here, in the previous table as well, we now push that into the previous table. That means on the next frame, if that key is still down, that is what we'll get. So we'll only get that key pressed flash once for one frame. So you just get one frame of that key being pressed. But likewise, if you release the key, so now this is releasing that key, we'll get a 1 here to say that key has been released as well. So we'll get a single frame where it flashes to say that it's been released. We use binary. Oh god, yes. You should be thinking. So you should be typing your numbers in hex, but the reason you type them in hex is because. Oh god, my nose is so itchy. Right? Every time I stream, my nose itches. Amazing music. What's this from? Circus Attractions. Okay. Yeah, whenever you write in hexadecimal, the reason I tell people to write in hexadecimal is because it makes it easy to then think about this in binary if you need to. So converting this to binary is quite simple. You know, you can look at each letter one at a time. So D, so that's 1 1 0 1. C is 1 1 0 0. 0 is 1 2 3 4. You know, everything's in blocks of 4 bits. Whereas if you in a decimal, that's really difficult to do. So definitely try and use hexadecimal where you can. Doesn't always make sense. Like, I mean, I've not used it here because I'm using 0. So I mean, it's a bit of a waste to type that in front of every single character. So that's just laziness. But yeah, I mean, you should try and use hexadecimal where you can, and use binary where it makes sense as well. So here we could set this to FF and store this here, but really we want to know exactly what this register is about setting, not an 8-bit number, but it's about setting 8 individual bits. So it's worth using a binary here. Same with this column as well. It's just definitely worth doing. Seeing decimal in ASM messes me right up. Yeah, it does with me as well. I mean, I do it. I mean, I think everybody does it now and again, but it does make things a bit messy if you don't. So that's why we're doing the exclusive OR here, so that we can have this key press table to just record what has changed in the previous frame. What's changed in this frame compared to the previous. I'm going to, so the value that we store in the key down table, I'm also going to push it onto the stack. Then when I've done these two things here and stored it, I can pull it back from the stack again and store that in key down previous table. So now what we should see, if this works, let me close the other one down, which is this one. Okay. So we go and have a look at our table again. So this is our previous, this is our current, and this is the key press. Now watch the key press very carefully. You probably will barely see it, but in fact, if I press it quick, you can kind of see it. So you can see how if I hold down F7, we get coincidentally the value F7 in both the previous and the current. So this is the current frame, this is the previous frame. And it will look like they're the same, but they're actually delayed by 1 frame. And that 1 frame is what you see here. If you look very carefully, you can see it flick to an 8. It will flick to an 8 when I press, and it will flick to an 8 when I release. But it's going to be so quick you barely see it, so let's slow it right down. You see that? So if I press, it flashes to 8 for 1 frame. If I release, it flashes to 8 for 1 frame. So now we've automatically got debouncing of those keys, which is beautiful. Because debouncing is another thing that can be a bit of a pain in the ass. So say you want to debounce all the keys, but you don't want to debounce delete, for instance. You might want to hold down delete to delete things. With this routine, you would read the key pressed for your keys. But if you want to delete, you would just check, is the delete key being held down? And if it is, then perform your delete routine. And you might stick a timer in there to make sure that it only triggers like once every 8 frames or something like that. Although that would still be pretty quick. So, alright, I'm going to take a quick break, guys. When I come back, I'm going to show you how to use macros to read these values in a really, really simple way. And we'll demonstrate that by making the borders change colours on various keys, different key events and such. Okay, I'll be right back, guys. We're back in 2 or 3 minutes. Be right back. Right, and I'm back. Didn't bother debouncing it, just made a time. Yeah, you can make a timer as well. So this way you won't get key repeat, and you'd have to code that in the way that Hayes has done it, but you could still use the table to do key repeat. You can also, if you want to do key repeat, you could just clear the previous table on a timer. So if we were to clear this table to FFF all the way along on a timer, then these would flash in line with that timer, so you could do key repeat that way, and then you get key repeat on every key. Hayes was so happy he's delete key. Yeah, it's what you want, because when you delete, you tend to want to be able to delete a few. So just playing around with the key press routine on my C64, very interesting. Cool. Delete is awesome. I always type my initials wrong. Best thing since sliced bread. Actually, I think copy paste is the best thing since sliced bread. I would have killed when I was coding back in my teens on the C64. I would have killed for a copy paste, but it wasn't a concept I was even aware of, I don't think, back then. So it certainly changes the way we do things now, that's for sure. I couldn't imagine trying to write a game without copy paste. It would just drive me mad. Or like copy line. So one of the common things that I do in Geekassembly is Control Shift D, which will duplicate a line down like that. It's a very quick way of just copy pasting one line down. So it's a very useful shortcut. Yeah, so this is the basics of our routine, and that's pretty much it. What we're going to do now is we're going to create some macros that we can use with this routine to make our lives super simple. So first of all, I'm going to introduce a concept in Geekassembly called a list. And a list is basically just an array, but it lets you reference. You can put lists inside lists, and you can kind of reference things by their index in the list, and so on and so on and so on. So I'm going to start. I'm going to put all the macros at the bottom of the file, and then we'll use them up here in this routine, and we'll do some stuff in here to make that to make use of these macros. And macros and functions. We're going to have macros to do the code, and we're going to use functions to do a lot of the kind of searching through the list and stuff. So we're going to create a list first. I'm going to call it the key list, and that's how you create a list. Very, very simple. You're probably used to seeing something like that in JavaScript or similar languages, in Java and JavaScript, but in Geekassembly we just need to type the name and 2 brackets like that, and now we have a list. So what we can do is we can add things to this list. Now you can add things to the list up here by doing this, and that creates a list of these values. And then if I was to just print out one of those values, if I do key list .get and I get the third one along, so it's 0, 1, 2, we should see down here that it prints out the value 2 when I compile, and you can see it prints out that value there. So that's basically how lists work. If you want to know more, read the documentation for Geekassembly, and you'll see all the functions that you've got to use in this, but I will demonstrate some of them now. So we're going to use this key list to store the keys that we're interested in. You might want to add every single key in here. You may just want to add the keys that you're interested in. I'm just going to do 1 or 2 keys for now. So what I'm going to do is you need to use eval whenever you change the value of something. So you need to reevaluate that. So I'm going to add something new to this, and what I'm going to add is a new list inside here, and then this list is going to contain the values for a particular key. So first of all, we're going to give a key a label. So let's do the X key, for instance. So the first value is going to be our label. Then the second value is going to be the column that it's in. So we look at X, it's in the third column, so starting with 0, that's 2, so we put the 2 there. and that's going to give us the index to look up in here that we're looking for in this one. And then we need to give it its actual value. So we'll look at the key list again. X is the last one here, so I'm going to give it this value here, 80. I'm actually going to type that out because I have some problems sometimes copying. And that's how we've defined this key now. Now you can add more information in here if you want. So you could, for instance, if you want to return a font number. So if we were using Petsky, then X would be 24. And this, we can use this to return a value if we want. But for now, we're just going to do it like this, and we'll add a second key in here as well. So we'll do shift, I think. Do it all in lowercase, and we'll look for a shift key in here. So have a look on this list, and we can see shift is in column 1, and it's also 80. So there's our two values. So now what we can do is we can write a function to do some stuff in here. So we're going to write a Getkey function, and this is going to take a key ID, which is this bit here, and this is going to return it's going to return one of these lists, basically, depending on which key it is. So the way this works is really simple. Just like a JavaScript program, we're going to go through the list. So we've got key list dot size. So dot size is the same as dot length in an array. If you've used lists and linked lists in other languages, you've probably seen size before. And then if we don't get anything, we'll just return -1. Actually, we can just return an empty list like that. There we go. So if we don't find it, we'll return an empty list. If we do find it, however, so if key list dot get I, so this is going to get the list in here, dot get 0, which is going to get the first element in the list. If that equals key ID, then we will return list.getI, and that's going to return this list here. So that seems fairly complicated, but I mean, it's not. If you've done JavaScript, this is very very simple stuff. Basically, this allows us to get these values at assemble time without having to do this manually for each key. It just simplifies these things quite a lot. So if we create a macro, in fact, let's just do a print at the end here. So if I do print and I do get key, and I want to get the key X, and I want to know what its column is, so get 1. So this should return 2. This should print the number 2 because that is the column that applies to that key. So why have I got an error there? Can I get Boolean return from value type number? What? Oh, that's because I've actually got to write a proper for loop. And there we go, you can see the number 2 being printed out there. And likewise, if I change that to shift, we should see the number 1. And there you go. So how can we use that to do more stuff? So this is where macros come in. So we're going to write a macro, and we're going to call this is key down. And this is going to take a key ID. And what this is going to do, this is going to create a little piece of code that's going to set a carry flag if that key is down or not. Okay, it's a function to return the matrix location of the key by layer. Yeah, exactly. Yeah. So is key down? So given a key ID, what we need to do is we need to then check if the key is down. So we're just checking if it's key down table. So we need to, first of all, we need to check, we need to set the X value to be an index into this table, and that index is this value here. So we need to always do it in square brackets. It just makes it easier to understand that there's something being evaluated here. So we'll get the key ID and get 1, and that should return a value in the X register here. We can test that straight away actually. So let's just put in here is key down. Really doesn't matter what we put here at the moment, but we'll put X in, and then we'll store that in the border. And we should see the border change colors depending on whether we press in Shift or X. So if we press Shift, it should go white. If we press X, it should go red. In theory, anyway. And that's not running because I've got that open. Has that failed? No, function size. Key list size. Okay, why's that failed? Because of that? Okay, maybe there's an issue with mixing. Seems to be an issue with mixing macros. Okay, that's... I wonder if I can do it with functions. Let's have a look. Maybe you can't do it with invalid token. Yeah. Ah, crap. Okay, this is going to be annoying. So, rather frustratingly, it seems like you don't have access to functions from inside macros. Okay, so let me have a think about this. There's got to be a way to do this. Because it seems like if I do this, there's a problem with that macro reading that value. Because it calls this key down, which is here. Let's try moving these to the top. It might just be some weird kind of the order that it's reading things in. So let's stick with functions at the top. Oh, it is working this time. Okay. Oh, it's setting the border color based on what I put. So I put X, so it's gone to 2. So annoyingly, it seems like this has to be done first. So what I'm going to suggest is that you put these functions into another file. So I'm going to call this keyboard macros. Put the functions at the top and the macros at the bottom. And that way you can import them at the top. Because I think what's going on here is because this is a multipass assembler, it reads through the code once and it tries to evaluate things like this as it gets to them. But because the function hasn't been defined at this point, it throws an error. So this will work if I just import at the top here. Import keyboard macros.asm. And there we go, we've got a red border, and if I put shift in here we should get a white border. Cool. Maybe in a different, but yeah, exactly, that's what it is. So you can actually see what's going on here, but it doesn't really tell you very much. But basically, the first pass it will try and evaluate all of these as it gets them, and it will do it in order. So it is a good idea anyway to have your macros imported at the top of the file anyway. And of course it keeps this file tidier as well. And actually this will give you something kind of neat and tidy that you can use elsewhere. as the important thing here is we're not actually writing any code directly into memory at this point. It's only when the macros are called themselves, like here, that they will be getting written. So we've loaded the X with that value, and now we're going to load the accumulator with our key down table, comma X. So now we have the list of the list of values. So we have the values for the column that key is in, and now we can AND that with the next value in the list, which is this value, which is the actual key. Where is it? Oh, it's at the top. It's this one here. And if that value is non-zero, that means that key has not been pressed down, so not pressed. I will put this here. And we'll have an exit here. So if it is pressed, what we'll do is we'll set the carry flag and then we jump to exit. Now, because this is a macro, we can't do an RTS. It has to be something like this. And we just do a clear here. So this macro will now tell us if the key is pressed down. So if we go in here, we call this macro. If the carry is clear, we jump to here. Otherwise, we'll increment border. And now, if we run this, we won't see anything, but if I hold down the shift key, we can see the border flashing. Weirdly, it seems to go for ages. I'm not sure why. Strange. Probably because it's the shift key. Let's try with the X key. The shift keys do have some strange behaviors. There we go. So only when I press the X key do we see that. Kick is very powerful, yes. So useful to know. Now I can change border in ASM and basic, yeah. Can't imagine. Yeah, I mean, this would take a bit of effort to convert these macros and functions into something that you could use in another assembler. But I think most assemblers have most of this functionality anyway. I personally prefer Kit because I think it does have more than most. I think I'm not sure if lists are available in other things. But what this means now is we can do things like this. So we can say, okay, if this key isn't down, we jump to here. And then we'll also check if the shift key is down. And now when we run this, if I press X, nothing happens. If I press Shift, nothing happens. But if I press both together, it works. So you can see, you can combine these things now to kind of work out if both keys have been pressed. VSM doesn't. Where do the key ID values come from? These are just whatever you want to put into this list. So, I mean, I'd recommend calling them the names of the keys. You could use font values. You could use whatever you want. So, did I write .cosmos with Kickass? I did, yes. Why doesn't 64 run on Node and Red? Can you imagine how slow it would be? I think it would actually be kind of cool to have a kind of shadow Vic, if you like, where it would only update the things on screen that had changed. That would be kind of cool. Because Python is better. No. No, crazy talk. So, likewise, we can do a really simple thing. So, is key pressed? And it's basically the same thing. This time we're going to look at key pressed table. and we're going to AND the two values together. But this time, because it's inverted, we need to do the opposite check here, like so. So basically what we're doing is we're taking the key value, we're comparing it to the key pressed table to see if it's just been pressed, and if it has, we set the carry flag. In other words, if the value when we AND these two together is non-zero, then it's been pressed, otherwise it's not. And so what we'll see now is the screen will flash once when I press X, and it will flash again when I release. So obviously we want it to only work when we press it, not when we release. So we need to do another check in here. Interestingly though, again, you can still use a combination of key down as well. So you should be able to see that if I just press X, nothing happens. Whereas if I hold down Shift and press X, things do work. So now you can kind of combine the two. JavaScript's just what I work in on a day-to-day basis. I do a little bit of Java here and there, not an awful lot, and I have done quite a bit of C# in the past, and I bet I've done maybe a couple of months worth of C++ here and there. It depends on what I'm doing, to be honest. I'd bet 6502. Yeah. Python is a streaming joke, yeah. Surprised Shannon doesn't like Python. It looks and reads like assembly. Yeah. Except it's not assembly, it's just a shit language, so. I use Python. I mean, I'm not adverse to using it. I just rather not. If I've got a choice of using something else, I will. But there are things that Python is really good at, so. Okay, so if the key is not pressed, then we jump to here. But now what we need to do is we need to do another final check here just to see if it's only just been pressed. So we need to check, is the key down as well? So what we will do is we will load key down table, X, and we will check it with our key again. And again, we will jump if it's not pressed. So now we should only get it if the key has just been pressed, not released. So if I run this now, I'll hold down Shift because I need to press X. You see it's only when I press down. So nice and simple. So next job is doing is key released, and we basically copy this entire function, this entire macro. And is key released is basically this bit here. Instead of doing branch if not equal, we do branch if equal. We just switch this branch over because now we're not checking if the key's been held down, but if it's not being held down anymore. And so is key released. Let's get rid of this shift key thing as well. So now when I press X, nothing will happen, but when I release it, we should see something. And sometimes you want that. Sometimes you want it so it's on a key release. But now you've got three macros here that will allow you to do is a key down, is a key pressed, is a key released. Nice and simple. It got a bit heated there. Python is similar to a few... Oh god, I need to catch up with this. No fan of Python here. I remember lots of things are in Perl and Python. It was new. Everything had to turn to Python. Yeah, Python 2 versus 3 is kind of funny. Perl has got its uses though. Perl is very good at string manipulation. So Python is similar to fewer languages for me, but it's everywhere. Yeah, Python reminds me of Ruby quite a lot. Way too easy to write shit Perl. Yes. PHP. Ooh. PHP is the bane of my life when it comes to security stuff. So I mean, it's good if you want to hack somebody. If they're running PHP, chances are you can probably get into their system somehow. So she says it when she Ruby is very pretty. Cool. So there we go. It's nice and simple. So let's use this to actually do something useful on screen. So what we can do is instead of so let's do it with this macro here. So this time we're going to do get key pressed. So what this is going to do is this is going to look, this macro shall look through the table to find out which key is currently being pressed, the last key to be pressed, and it's going to return a value from that. So I'm going to add a new value in here, and this is going to be the character code for that value. So there isn't one for shift, so I'm just going to put I'll put 0 in here for that for now. Let's add a couple more. Let's add X, Y, Z in here and have a look for those in the table. So so Y is here, so it is column 3 and 0, 2. And that's character number 25. Z is character number 26, and Z is at column 1, and it's 1, 0. So get key pressed. So we're going to need another function here. We'll call it get current key. And this is basically going to look through the actually no, it can't do it through this. How do we do this? Get key pressed. Okay, so what I want to return from this function is this number here, depending on which key has been pressed. So I want to first of all cycle through, let's get rid of all this code here. So I want to cycle through the table. So I'm going to create a 0 here, and we'll load our key pressed table, comma X. And if that's equal to 0, I'm going to call this a loop here. If that's equal to 0, then I'm going to skip over, and then I'm going to increase X, X to 8, approximately, like so. I'm not going to RTS for now. I'm going to call this found. Actually, I am going to put an RT. No, it's not going to be RTS, so I'm going to have found and exit here. So this is a little bit more complicated because this is an actual kind of key read routine. Oh man, people are really into talking about the languages, eh? Oh god, yeah. What? YAML. Yeah, we use that quite a lot for tower jobs and stuff. Okay, so if we find a value, so if there is a value in this table, then we have recorded it in the accumulator and we can just jump straight to found. Otherwise we'll jump to exit here. If we have found the value, this can be 0 here, so we need to reset that. If we have found the value, then the X register and the accumulator will point to a column on our row. So in which case we now need to find the key in the table that has that column and this row, which might not be that easy to do actually. I'm just thinking if this is going to be simple or not, because this is compile time, so this probably isn't going to work with tables. This isn't going to work with list even, so yeah, this would have to be something different. So the way we'd have to do this, we'd have to have a table, which I will put a table in Actually, I think I've got ones. Hang on, let me do another Luna's guide in, because I remember writing it. Intro. Yep, there we go. Key lookup. So I'm going to copy that. So this is basically just a list of all the keys on the keyboard. I'm going to put it in here. And basically what you can do now is once you know which key is being pressed, just here, accumulator is going to be our row, X is going to be our column, which means we need to first of all pick a row. So let's just make sure that these values match in here. So let's go and have a look. Yeah, so these are going... I don't have the numbers in here, annoyingly, so I should probably put the numbers in. 3579, okay, so 3579 plus £1, okay, plus £1. So I trimmed this table down because I didn't want every character being available. I'm going to move this over to this screen so I can actually see it at the same time. Because for the Luma code entry, I was only interested in the letters. So I'm just going to fill this table out now. So this becomes 4680 minus 4860 minus a clear home, yes. ZCBM full stop space SFHK colon equals an up arrow. I'm not going to put the up arrow in, so XVN comma slash. Okay, it feels like there's a lot missing there, but that'll do. So now I just need to make sure that these values work properly. So what I'm going to do is I'm going to push the accumulator onto the stack. Then I'm going to transfer X to the accumulator because X is going to be 0 to 7. Then I'm going to multiply this by 8, which is going to give us a row offset. So to do that, I need to shift to the left 3 times. And then I am going to... where do I do this? I'm going to use the temp here. See, I've used... Just make it consistent with that. So store that at key temp. Then I need to pull the accumulator and add it to add key temp to it. I could use any 0 page address for this, but this is fine. And then transfer that to the X register and then load accumulator with key lookup. X. And hopefully get key press now should return well, let's have a look. Let's just comment that section out. So this should return a 0 if no key is pressed. It doesn't have a key ID here. However, if a key is pressed, it will return a value. So what I'm going to do is I'm going to create a very simple index here. I'm going to set that to 0. Then I'm going to if equal here. So if no key is pressed, it's going to jump to here. Otherwise, I'm going to store the accumulator at 0400, X. I'm going to load X with index, and then I'm going to increase X and store X in index. It's quite a lot of code. See if it's worked. Helps if I actually put the right things in here. Okay, I think my table's the wrong way around. Because I'm getting strange values. Okay. That's fine. It just means I need to flip these two values around, so instead I am going to let's try that thing around. Oh. I had a feeling I'd get those columns wrong. Nope, I'm getting strange values. It's not quite right. Also, this is only reading the key pressed, so I need to actually read the released as well. So here I need to check to AND that value with press key down table, comma X. If that is, let's see, if that is down, if that is 0, it would be there, I think. Jump found. Now I have to load that value again. I was only doing it on release. Okay, so I need to change that to not equal. Okay, so it's kind of working, but the keyboard lookup is completely wrong. Oh, I think I know why that is. So we need to convert the value. So the X value is correct, but the accumulator value, this value here, is incorrect. And the reason why this is incorrect is because this is actually in powers of 2 at the moment. So the easiest way to do this would be to count, basically. So I'm going to set the Y to 0, and then what I'm going to do, key press table. Yes, so that's what I need to do at the end. So I'm going to take that value. So this is going to be 0, 1, 0, 2, 0, 4, 0, 8, and so on. So what I'm going to do is I'm going to shift that value to the right, and if the carry is set at that point, then I'm going to jump ahead to here. If the carry is not set, so I'm going to call this shift loop. If the carry is not set, then what I'm going to do is I'm going to increase Y, and I'm going to jump to shift loop. And it's going to keep doing this until the carry is set, which is going to give us a value. It's going to change this into 0, 1, 2, 3, 4, 5, 6, 7, basically. It's going to do the is it log, I think it's called, in maths. Switch M and N. Oh, God. Yeah, so this will give us that value in the Y, then we transfer that to the accumulator, then we need to do all this. Okay, so hopefully that should fix those issues, but I bet now it's the wrong way. But I've got the table flipped. So let's have a look. Yeah, well, my table is flipped now. Okay, so flip the table back around again. So Transfer the Y to the accumulator, push that accumulator onto the stack, transfer X to the accumulator, shift this, and pull this from the stack. There we go. No, my keys are still wrong. A, B, C. So, right, I'm pressing A, and I'm getting W. So it's like 1 to the right. So if I press 4, I should get A. No, I get R. Oh, it was the right way around. God damn it. Okay. This is where the rows and columns are important to get the right way around. I'm making a pig there of it at the moment. I've made my own Enigma machine. Yes, it is. Let's check what's happening. A, I'm not seeing anything. Right, let's try with W. W, I'm not seeing anything. R, C W, Y, I see R. Okay, so these values are back by 1. So if I press P, I should get I. Yes, okay. And that's probably just because... let's have a look. That would be the row number is wrong, which is going to be the W. Let's look in here, find W. Okay, so it's the lower number. So it's this value in X. That can't be right. Because that's implied I need to do that, and that doesn't make any sense. So I'm going to try that. I don't think that's right. No, see, it's come back. It's gone somewhere completely different now. And it's giving me X. And let's see, yeah, okay, so it's not that one. Let's try and increase this. God damn it, this is the problem with doing this code right. Oh, there we go. That has worked, you know. 3 has drawn 5, 5 has done 7. Okay, some of the keys are wrong here. So I would like to work out why. Thank you for the follow, Roland V Drums. Maybe a silly question, do you not use the kernel? You can use the kernel, but obviously if you use the kernel, that means you're limited to using that space for kernel. You can kind of turn it on and off, but the reason I'm doing this is because there's enough people here who have asked this question about how to do this, so I thought it was a good idea to do it. And for me, the macro that I'm doing now, this key press macro, is kind of unnecessary for what I need it for, but I'm going to try and get it working in here anyway, because I think it's a useful one for you guys to have should you want to go down that route. So question is why is these values? So let me just stick a pause in here and see what values I get at the other end. Okay, so I want to see, actually let me put that break here. I want to see what my X and Y values are when I press a key. So I'm going to go into the debugger. It could just be that this table is completely freaking wrong, which wouldn't surprise me. I mean, although it looks fine to me, so I'm not sure why it would be wrong. Okay, so let's press a key. So if I press G, we should have 2 and 3 in X and Y, and we've got 2 and 3. Yeah, so 2 in Y, 3 in X, and if I press F11, we see a G. Okay, so if I press 3, this was a problem. I got 5. Okay, so press 3. The values I get are Y0, which is correct, and X1, which is correct. So I don't know why I'm getting the wrong value there. So that should be this value in the table. So let's put another breakpoint in to see. Let's keep that one there, and we'll put another breakpoint in here to make sure that the X register we get at the other end is correct. Oop, not that one. Instead of doing macro load x and an AA commands, can't use kick command. No, because if we're changing the value of the if we, what are you trying to redeem there? So the thing is, might want interrupts for cursor. Yeah, you might want to use interrupts to do the cursor flash. No, you can't use the X register like that because it's macros and the kind of evaluations, the plus, the minuses that you see in the square brackets are all done at assemble time, and obviously the X register, we don't know what it is. So okay, yeah, I didn't hear that, by the way. I don't know why I didn't hear that. I think I just read it rather than it actually work. Yeah. So kick math is all done at assemble time, so you can't have you can't use the registers as part of those calculations, which is why I'm having to write this function like this. So yeah, let's press 3 again, see what happens. So it's correctly saying that our 0 and 1, which is indeed 3. Yeah, passing X into the macro. I'm not passing anything into the macro, I don't think. X is from here. Oh, you're testing, okay. Oh, you're saying avoid it. Yeah, definitely. Instead of macro, doing oh, the original key press macro. Because this macro is based on a single key ID. You would have to check each key individually. Whereas this function is just looking at all the keys and returning which one has been pressed. So you can't really use the value from here, and you can't use that, for instance, because you can't know at assemble time which key is being pressed. You have to check every single one. So, oh, pardon me. This is delicious, by the way. I'm saying the original macros, you can pre-compute the address, but you can only do it for a single key. That's the problem. This is checking all keys. I think that's what you're getting at. I'm not entirely sure. Feel free to drop some example code in Discord to me if you want. Is it better than wine? No. Although I would like to mix it with something. I maybe like to try this with vodka or something. It's really nice. Are you on about this one here? Yeah, no problem. Take care, Andira. Thank you for joining the stream. So you're saying get rid of the X here, because it would be pre-computed from... Yeah, that's a really good point. Actually, we'll do that in a second. Thank you for it. That's a really, really good point. So as Foro points out, we're actually using $X all over the place here, but actually you can do this a lot quicker. I'll do that in a second. Let me just fix this function and then we'll do that. Yeah, I got it. I got it in the end. It will make that function way more efficient, you're correct. And it will save you from using the X register, so you can do what you want with the X register. Okay, so we're at this point, our row and column is 1, so that should be the number 3. When I jump to the next point, it's actually giving me an X register value of 2, which is incorrect. This should be 1, and that's why we're seeing 5. So that means this calculation here is wrong. So which is that increment there, which should not be there. Okay, let's try again. Let's close down the old windows. It's okay, yeah, I'm too sober. Redeem tequila. Oh, I wish I could redeem some tequila right now. I have got no tequila in the house at all. This is kind of depressing. So, Y and R is 0 and 1. Y and X is 0 and 1, which is correct. Jump to here, that's correct. So we should see the number 3 print, which we do. Okay, so let's try the number 5. That's giving us 0 and 2, which is correct. Skip that ahead, gives us 2. We should see the number 5. Okay, so let's just turn that breakpoint off here and here, and see if I can type some values in here now. No, see, some of these values don't work. So I don't know why that is. Right, I'll go back to that in a second. Let's just do this fix. So what we're doing is we're loading this value and then we're using it as an index into here. But what we could do instead is if we wrap this whole thing, get rid of the X, and just add that value like that. That means we don't need to use the X there at all. We still need to do that there, but we can do the same thing here with a key down table. Instead of using the X, we can replace it with this. It's a very good point for it, because it means that we're using less cycles to do this. Using less cycles, and we're do it here as well. And we're not using the X register as well, so that means the X register is free to do whatever you want to do with it. It's not going to get bashed by these macros. And to be honest, the shorter the macro, the better. You always want to try and keep macros as tiny as possible. Because these do get copied into code every single time, so... So there we go, it's key release, it's key pressed. Let's do it in key down as well. I'm going to move this is key down into the bottom section somewhere. Cool. Let's move that down here so it's with the others. And just demonstrate that that still works as well. So let's just get rid of this bit for now. Just do this. So we need to press Shift and X to increment the border. Oh, why's that failing there? What? Why is that suddenly not working? Getkey. What? Ah, okay. Maybe use bit instead of compare and use end flag instead of C flag to be more efficient. Yeah, I'm just wondering, we've got a problem with the passes now. I think because we're trying to... This should work. That's... Maybe if I get rid of the brackets around it, is that going to fail at the same point? 88, line 9, line 88. Okay, where's line 88 here? Let's pull that one back. So look at line 88. 88 is this one here. I mean, brackets shouldn't matter, but no, it definitely doesn't. Okay. Try locking the variable. Yeah. Okay, I'm just gonna revert those changes for now. I'll have to have a think about those. I definitely get the concept, but it doesn't seem to like the multi-pass nature of Kick Assembler for some reason. So I will address that again at some point. But for now, I'm just going to put it back to get the other thing working. Very strange, though. Okay, Shift and X. Okay. I don't know why that breaks like that. It's going to be something to do with the multi-pass stuff, so... I'm going to go for a quick break in a second. Just trying to use an unlocked variable across passes. Really? How do you lock a variable then? What do you mean? I've never locked a variable. Teach me something, Hayes. Teach me. Oh, okay. I see. Okay. When a value is locked, dot lock. Okay. When a value is locked, it becomes immutable and column from the content. Ah, okay. Simple. Alright, let's... God damn it, can I redo in here? Please let me redo. Control Y, okay. Oh, no, that's not it, is it? What the hell is that? Well, let's just try it with one function. So let's do it in this is key down thing, so... Oops. Oh my god, what is going on? Okay. Plus hit key. There we go. So just going to do it in this function. I'm going to see the error and then we're going to fix the error, hopefully. So the error says... So look at the error. Oh, it freaking works in that function. That's annoying. What? What? Alright, let's do the next one. This one here. I'm going to wrap these in square brackets every time, just makes it easier to read. Okay. So what about this one? Was it just this one function that was causing the issue, or was it just because I moved the code somewhere? I bet it was just because I moved the code somewhere. Because if this works now, that's just frustrating. Wait, is it because I'm not actually calling that function anymore? Okay, there we go. Right, so... Okay, so... I assume we can lock at the end. So I guess we just need to do eval key list dot lock, maybe? Or maybe we don't even need to do the eval here, but let's give it a try. I'm trying to use an unlock value across passive. I'm not trying to use an unlock value because... Or maybe I have to do it on the very last bit here. Or maybe I have to lock each one of these individually. Yeah, Yeah, I'm not convinced that that's going to work for me, unfortunately. Dot lock to the end of the list. Yeah, that's what I was doing. It didn't work. So, all right. I am going to revert everything, and I am going to take a look at this at another date. Oh, too far. God, how far have I gone? There you go. Yeah, I think it's just because I'm combining functions and macros and lists all in one. There is a bit of that in Kik. It does take a bit of getting used to, but I've never had this value either myself, so I'm not sure why it's a problem. It's fine. I mean, this works as it is now, so you can always feel free to kind of change this up however you want to. So. The macros are, well, they're all imported at the very top here, first thing. So if you're at a tuning goat track, I can load it into an assembly game. Yep, you have import. In fact, I think you just have load SID, I think. Yeah, there you go. Alright, I'm going to take a quick break. When I come back, we'll work out the last bits of this key press routine. It's 11:30 now, so yeah, I'll do another hour or so. Yeah, I don't know why it doesn't work. It may be because I'm using lists within lists as well. It's one to kind of have a play around with afterwards. Alright, I'll be back in a few minutes, guys. Be right back. Yeah, I was just reading that same thing. Alright, come in. Let me fix the key fetch thing first, and then I'll take a look at that. This isn't on Flubits, Chromos. I only do Flubits on the Saturday stream. This code will be on GitHub straight after, though, as soon as I've finished. It's 1571. 1571 drive. But actually, my Turrican disk came today. I got a bloody UPS note through the post to say that it had been delivered, and I wasn't in, but I was. So now I've got to go out and actually get it, which bothers me a little bit, but I'll pluck up the courage to go out with a mask on or something and grab it at some point. I've got some masks around somewhere. I'm going to box them down there. Okay, right, we're just looking at this keyboard macro. Why is it grabbing the wrong value? I want to know. So I'm going to run this, and I'm going to press some key in the middle somewhere, M or something. Oops. So if I press M, okay, I get nothing. Wait, is this even running? Oh, because I've not got my key press routine. Okay, let's run the key press routine instead. Actually, I can leave both of them on, it doesn't really matter, but I'll just run that one for now. So basically, when I press a key, it should tell me the row and the column here. So it's row 4, column 4, which is M, which is correct, 4 and 4. So that should translate into 32, 36. So the X register should now change to 2, 4. Is that right? Yeah, 2 4. And I get 2 5 for some reason. So I'm going to step through this a little bit and see what happens. So let's just run it again. Oh, I do get an M though. Hang on, is that right? That doesn't feel right for some reason. Okay, let's find a key that fails. Okay, so press T, I get a T. Press U, I get a U. Okay, press 3, I get a 5. Okay, so if I press 3, it says that my column is 1 and my row is 0, which is correct. And in the key table, that would be index 1 in the list, but we're getting index 2. So let's have a look why we're getting index 2. So we multiply that by 8. So yeah. So that means it's 0. Oh, we've got this increase x again. We need to get rid of that. That's what's wrong here. Let's get rid of that. Right, okay. Damn it. This is what happens when you do live code. So let's find a key that breaks. Did I 0 the counter? Yeah, I believe so. Let's find a key that doesn't work and then see what happens. Okay, so when I press M, I get B. So if I press M, it's saying my column is 4 and my row is 4, which is correct. So this should be translated to, well, it should multiply the 4 by 8, which it's doing here. So let's just skip through this a little bit. So it's 2 0, which is correct. Transfer the x to the accumulator. So that's 4. Then add those two values together, which gives me 24. Okay, so maybe I just done my table wrong. Let's have a look. 2, 3, 4, 6, 7, 8. So this would be this one 4 wrong. It should give me M, but for some reason it gives me B. Am I missing a character in here somewhere? Is one of these characters not registering properly? Maybe these characters aren't registering properly in memory. So let's just align this. Put a key lookup in here so I can see where it is. I'm just going to go and have a look at it. I have a funny feeling it's not registering all those values properly. So key lookup is at 0900. So I think the routine's pretty solid. 0900. Here we go. So three 579. Yep. Said CBM. C. Yes, it's actually added an extra character in somewhere. So which one is wrong? ADG. So it gets wrong before then. Ah, for some reason, this plus pound sign fails. Is that some kind of escape character or something? That's what's wrong. So you can see, let me just show you in here. See if it does it again, maybe. Yeah, I'm setting screen code upper. That should work. So if I go to 0900 in here. Yeah, see, it adds this extra character in here for some reason. So when I do a plus, it adds an extra character in. It is, I think it's either making pound or plus a double byte. Let me get rid of the encoding and see if that changes it. Oh, that's not what I wanted to do. Just do it here. From step, do you have to set char set? Yeah, I thought screen code upper was the right one to use it, but maybe I'm using the wrong one. No, it's still added it in. Okay, so you need to figure out what that encoding is going to be. So let me just look for encoding in here. Screen code upper, screen code mix, ASCII, PETSCII upper, PETSCII mix. Let's do PETSCII upper, see if that changes things. There seems to be some control character in there. No, there isn't a workspace for this stream now. Indeed. So that's why we're getting issues. The actual code was solid, but the characters are wrong. It's still giving incorrect characters here. So 5 plus M. Yeah, it's giving me. Let me try PETSCII. Let's try PETSCII mix. ASCII. Yeah, let's try ASCII first. ASCII's going to give me very, very weird numbers, I think. Valid encoding. What? Let me try PETSCII mixed for a second. This is the problem, is these freaking characters. It's going to be one of these two characters is wrong. ASCII seem to not allow at all for some reason. I mean, it's easy enough to fix manually if I have to. Yeah, that's giving me something completely wrong. So what I'm going to do instead, because it's just that one character, so I am actually going to split this into 2 lines, and I'm going to put the bytes for the remaining characters. I forgot what they were now. Plus pound and 1. Okay. So now I need to get the PETSCII font. Plus pound and 1. Okay, so plus is 2B and pound is 1C. So 2B, 1C, and 1 is 3-1. I don't know why. I can't explain that. It could be a bug in Kick Assembler, possibly. See, now I'm not seeing anything. Oh no, see, look, it's still after the plus, between the plus and the pound sign, 2B, 1C, it stuck a C2 in there. That is really bizarre. And also, oh, because I've still got them in here, that's why. Fucking idiots. Yeah, thank you, old school coder. I'm glad someone noticed. And the real Seabag notice as well. Bonus points to you both. Okay, hopefully this should bloody work now. There we go. Right. So let's take the breakpoints out and do some tests. I'm going to try typing the alphabet out. That's kind of dotted around enough. G H I J K L F Q R S T U V W X Y Z. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. There you go. Let me set it first. Oh, yep, you need to delete the original values. Yeah, extra bonus points for Foray. We're forgetting there first. 2 bonus points to Foray, 1 each for old school code and real CMake. Yeah, cool. So that's kind of working. I'm not keen on that. I don't know why that value was causing an issue. I can only imagine there's some weird text encoding somewhere. I couldn't, for the life of me, tell you why that's doing that. but this works now, so let's get rid of that. Okay, cool. Let's have a go at fixing this sort of thing there. So this function is probably not the most efficient in the world, but it does do the job. And we'll actually get the key that's currently being pressed. I would suggest actually that this should be a method in here. So let's get rid of it out of here and let's put it down here instead. And instead of making it a macro, we'll just call it get key pressed, like so. We just put an RTS in here and an RTS here, just because you wouldn't want this to be inserted every time you do that, so you're better off just doing it as a function like that, as a method call like that. It still works exactly the same. Cool. And we can combine the two, so you can still use the original stuff as well, so you can still have all your typing in here as well, but Shift and X still does that, so you can combine the two together. So I'll leave both of those in place. Right, let's see if we can tidy this stuff up. So what the Kick assembler manual seems to say about this is, let me just find where that was. Define user defined structures. Okay, so it seems to point to, if we do this, that's not showing up at all. Hang on. Where was that defined? I read something. Mutable values. There we go. Define. Okay. Because that would imply that this should work. Maybe I need a newer version. Maybe it's a new thing. Let's see what happens when I run that. I have a feeling it's gonna fail. Why is define not working? Is this a new thing? The values previously determined are immutable, so change kick some between you have to lock mutable values to use over the pass. You can call its lock function, or you can define it inside a define directive, which is what I'm doing. Oh, dot define. There we go. Okay, that seems to work. Let's just make sure that's doing everything there. Shift and X is still doing it. Okay, right. So now they're defined up here. Hopefully we can change them down here as well. So let's try that right here with this bit. See if that actually works. Seem to work. Cool. I think that's working. Right, in that case, let's go through and change all of this to be neater. So we're going to do this one here. And this one here. Get rid of that. And get rid of that. Like that. There we go. Cool. And we've got there in the end. Cool. Awesome. So we don't have delete working. Let's implement delete while we're at it. So we've got a few things going on. So this should be a nice little standalone file there. If you want to move some of the other functions into here, what you could do is you could move this. In fact, let's do that. Let's tidy this up a little bit. Let's make it a code import as well. So as well as the keyboard macros in here, I'm going to put all of this stuff in there as well. So all of this I'm going to put in the bottom of this file. So I'm going to put it at the bottom to make sure everything is defined before it. And this should still work, but now it's all contained within a single file. So you import this file. It's going to import all the macros you need, all the functions you need. If you import that right at the beginning of your file, before you use any of these functions here, make sure you call key scan once per frame, and then you can do what you want. So I'm going to put a note in here, call once per frame to update keyboard values. And then you can do whatever the hell you want here. So what I'm going to do now is I'm going to do a check to see is key down. I'm going to call it delete. And then I'm going to go and look up what the delete button is. So it is... So we need to add it to the keyboard macro. So you add any keys you want to specifically reference in here. So at the moment we're only using Shift and X, so I'm just going to put those two in. I am going to add a new one in, which is going to be delete. And that is, and we don't need these character codes anymore, so get rid of those. So delete is, where is delete on here? Insert delete, there you go. So it's column 0. And the value is 0, 1. So is key down delete. If it's not down, I'm going to jump to here. Otherwise, what I'm going to do is I'm going to load the accumulator with 20, which is the space. I'm going to store that at 0400, X. And I'm going to load X with index. And then I'm going to increase X, store X with X. So there we go. This is going to delete very fast though, so see, there we go. It actually deletes off the end here as well. So we could do a check in here as well. So set index like that, and just make sure that's 0, then it's not going to go off the end of the screen. And we could do the same check here as well. Like so, there we go. So now I should be able to type all the way to the end. It's going to take forever, this. So. And when it gets to the end of the 255, which is the length of the field that we've set, it's just going to change the last one. But pressing delete will delete the whole thing and should stop at the top. There you go. Cool. And you could create a flashing cursor quite easily here as well, just by setting, well, let's do a flashing cursor as well, why not? So here, I'm just going to create a variable here, I'm going to call it timer. And then I'm going to increment timer. And I'm going to end it with, oh, let's see, how do I want to do this? So I want, let's end it with 20. That means if this bit is set, the bit for 2, then we trigger it. If it's not, we don't. So just let me put here. And we'll have a value which will be 20 A0, and then here we'll just transfer to the accumulator and store that at 0400 where X x's index. Not flashing though. Why is it not flashing? Oh, because I need to. All right. I've got a flashing cursor as well now. Cool. I think that's about it. I don't think there's much more I can do with this routine, but you can see how just by kind of setting those functions up now, we've got a nice little routine here, a nice set of routines and macros and functions that we can use to do all sorts of keyboard entry and stuff in here. So, and you can now see that the keyboard entry is actually quite simple if you look at it. If you just got rid of, that, I'm just going to comment it out because I'd like to keep that in there just so you can see. I'll make that keep pressed as well, so it's there as a check. You can see, you know, we're actually doing quite a lot of stuff here. We're taking a key, drawing it to the screen, we're deleting if we need to, and we're flashing a cursor, and we're doing it in about 30 lines, 30 to 40 lines. And can you read Joy 2 in the main loop? Yeah, so let's do that down here. So we're going to load the value from DC 100. I'm going to ignore this. Well, first of all, I'm going to AND it with 1F. And then I'm going to ignore it with 1F. Ignore it with 1F. And then store that in D020. And so now I can, this is my joystick now, I can change my joystick values and the border updates accordingly. Up 1, down 2, left 4, right 8. And fire you won't see because it's 16, it's just going to be 0 again. But I can still type in here, I can still use my joystick in here as well. So you would also want to store the text in the board. Yeah, I mean it depends. It depends how you want to deal with the text. I mean, this is just a very, very super basic implementation of drawing the text to the screen. But yeah, what you might want to do is as you write, you might want to kind of copy that value not only to the screen but to a buffer, depending on what you want to do with it. But yeah, you know, joystick still works at the same time, which is kind of cool. I can be typing stuff and doing stuff in here as well. Kind of cool. You will get some conflict between joystick and keyboard. That's just natural because they both use the CIA. So actually holding left doesn't cause a problem, up doesn't cause a problem. But you may find sometimes that you will get some weird behaviors with some keys when you're using the joystick at the same time. But so yeah, you could use this to do keyboard entry as well in the keyboard with the joystick if you wanted to. It's entirely up to you how you implement it. The whole point of this kind of stream was to show you how to write a kind of flexible, reusable keyboard system without using kernel, and I think we've achieved that. I think it's worked quite well. I'm quite pleased that actually I'm going to be using this in some of my games coming up, so it's pretty good. Quite pleased with that, and hopefully it should work with some of the keys as well. Plus underscore doesn't work unless there isn't an underscore. Yeah, I mean the keyboard mapping is terrible on this, on Vice to keys, but yeah, you can see I can type some of these characters, yeah. And if there are characters missing, which there shouldn't be for the most part, you just need to add them into this this lookup table here. So at the moment there's just @ symbols when it doesn't know what the keys are. So I think if I press return, I'll probably get an @ symbol, but you can change what you want. Yeah, multiple key presses work. So as I said, with this with this section here, you can detect multiple key presses. So if we did W and A, for instance, if we had those in, is key down. So we're checking for let's leave the original code in. Let's just copy it. And let's put W and A in here, and let's make it both with key down, because we're interested if the key is down, not if they've just been pressed. If you wanted to debounce two keys together, you'd have to do it by doing it like this, checking if one is pressed and the other is down, unless you want it to be very precisely pressed at the same time. But we'll just check if both are down. So we do W and A, and we'll add these in here. So let's add two more in here, W and A, and that would be both in, hang on, have I got this correct? Yeah, both in, oops, both in column 1. This one is 02 and this one is 04. Again, it depends if the computer itself can handle it. I'm not sure, because these are both in the same column, so we'll have a look. So if I press W, nothing happens. If I press A together, you can see the border is changing down here. I don't know why it's changing back to black. So, because I'm doing the joystick routine. But yeah, you can see if I press W and A together, it does detect that both have been pressed together. But individually, nothing. I have to press them both. So it does detect multiple key presses as well, which is good. And it will detect as many as you need it to, check, up to the point where the Commodore itself will start having hardware problems with detecting those. So, and that's because we're not kind of filtering out individual keys. We're recording all the keys that have been pressed, and we're storing the entirety of the key presses in these tables, and then using kind of logic, using exclusive OR logic to work out which keys have actually changed in state, and the macros will kind of utilize those as well. So I mean, I think this is better actually than the kernel routine, because the kernel routine probably wouldn't allow you to detect multiple key presses like that. In fact, it definitely wouldn't, because it's more of a text entry than it is a key press thing. I think you can. No, I don't think you can actually with a kernel. I think you'd have to do it this way to get multiple key presses like that. But yeah, you could use WASD now as a control system in a game. But yeah, that's kind of about it really. I think I'm going to leave it there then, guys. It's been pretty simple, so I was quite pleased with how that went. Learned something new as well in the with the define thing. So this is how we lock a list that we've updated like that. Only tools are shift Commodore keys and run stop restore. Yeah, it kind of makes sense. Maybe you can document where those files come from and URL in the comment for that table. For this one here. Okay, let me taken from, there we go, the define key list. Yeah, so key ID can be any string, but recommended something representative. And one is the column number. The column number as specified in PC00. Up to 7 to row value. The row value as specified, so inverted in PC01. This would be 01, 02, 04, 08. There we go. Do a keyboard routine if that's 6 keys. Yeah, I think it depends on which columns and stuff. There is some weird kind of stuff with the way the CIAs are wired to the PLA. So I think you have to kind of. I think, yeah, 6 sounds about right. I think it just depends on what keys you're pressing. But if you compare that to like modern keyboards, that's actually pretty good. The Commodore was pretty decent at doing this sort of thing. You certainly struggle to get that many keys reliably on modern keyboards. Again, it depends on the keyboard. Like, so gaming keyboards tend to have anti-ghosting hardware in them to prevent the kind of prevent errors when you press multiple keys. But like a really cheap PC keyboard will have all sorts of problems. Cool. On that note, I'm going to find someone to raid, and I'll upload this code straight after the stream for you guys to use it as you will. If, by the way, any of this code, if anybody finds a way to improve it, please feel free to create a pull request on the GitHub and send me a message. Just let me know, because I probably won't see it unless you tell me, and I'll gladly do my best to look it over and get it into the code. So you know, all of these things are for everybody to use, everybody to share. That's the whole kind of point of it, really. So Mr. Cola's on. Let's go and raid Mr. Cola. I don't know what he's doing. It was, I have no idea what that is. I need to have a look. Oh, it's on GameCube. Cool. I do want to do a GameCube stream at some point. As I showed the other day, I've got my lovely PC Engine. I've got my lovely orange GameCube that I do want to mess around with. Maybe I'll play a bit of Vic Karuga on Saturday night. Right, let's go and raid Cola. Yeah, cheers guys. Cheers for coming along tonight, and I hope you've learned something. I've learned something. It's pretty cool. I will be using Define a bit more often now to try and avoid some of these issues. All right, I'll see you guys on Saturday, where we'll try and finish off the intro, or at least the basics of it. Maybe get the oh yeah, I could have used the hash table. Yeah, that's a good point. Maybe get the transition fully in place, and we'll see where we get anyway. So yeah, thanks guys, and I'll see you all on Saturday. Take care. Bye.
Everybody from Challenge Stream. How you guys doing?